Geographically speaking, the continents of Europe and Africa are practically touching. They are separated only by the Strait of Gibraltar, a narrow 8-mile gap of water connecting the Atlantic Ocean to the Mediterranean Sea. To put that distance in perspective, on a clear day, standing on the southern tip of Spain, you can literally look across the water and see the African landmass with your own eyes. Building a direct physical link across this water would unite the 447 million residents of the European Union with the 1.4 billion people living in Africa. The economic incentive to ease transportation and supercharge trade between these two massive regions is enormous. And spanning an 8-mile distance is standard engineering. Right now, there are over 60 bridges around the world that easily exceed that length, crossing vast bodies of water without a problem. Yet, despite the obvious geographic choke point and the highly lucrative potential, this specific stretch of open water remains empty. Bridging this 8-mile gap is a certified engineering nightmare. To find out why, we need to draw a theoretical blueprint and stress test it against reality. The first obstacle for our blueprint sits right on the surface of the water. Any physical structure we build has to accommodate an immense volume of marine traffic. This chart shows exactly what we're up against. Roughly 100,000 cargo vessels pass through the Strait of Gibraltar every year. That dwarfs the 14,000 transits at the Panama Canal and the 20,000 at the Suez. On a busy day, around 2.4 billion gallons of oil float right through this gap. Because of that non-stop daily flow of massive ships, a traditional drawbridge is entirely out of the question. It would have to remain open almost constantly, creating permanent miles-long traffic jams for any cars or trains waiting to cross. So, to keep from blocking trade, our hypothetical bridge must be built permanently suspended. And to clear modern vessels like the massive evergreen container ships, the roadway has to be hoisted over 100 feet into the air. Because the strait acts as the primary artery for the global fossil fuel and cargo trade, any bridge blueprint is forced to become a towering, sky-high megastructure just to avoid severing the global economy. Building high into the sky is only half the problem. We also have to anchor this massive structure down to a seabed that plunges roughly 1,200 feet deep. And waiting at the bottom is the Azores-Gibraltar Transform Fault. The African and Eurasian tectonic plates meet directly underneath this waterway, violently grinding past one another. The 1755 Lisbon earthquake, estimated to be between an 8.5 and 9.0 on the Richter scale, shattered Portugal, Spain, and Morocco, proving exactly how lethal this specific fault line can be. To make matters worse, the seafloor here isn't solid rock. Geologists discovered the strait is riddled with deep quaternary clay channels, layers of soft, unconsolidated mud that easily shift and crumble under heavy pressure. Building this bridge requires balancing a 100-foot-tall, miles-long concrete highway on top of shifting mud, sitting directly over an active earthquake zone. The physics guarantee an eventual catastrophic collapse. Let's assume engineers somehow invent a way to beat the geology, maybe by building a $20 billion floating artificial island bridge, which has actually been proposed. We still have to figure out who owns the land and who pays the bill. The map in this region is fractured. The critical northern port on the European side, Gibraltar, isn't controlled by Spain. It's a British overseas territory, and Spain has wanted it back for centuries. Meanwhile, directly across the water in Africa, Spain controls its own territorial port cities, Ceuta and Melilla. Morocco fiercely claims these Spanish enclaves belong to them. Spain wants Gibraltar from the UK. Morocco wants the enclaves from Spain. And all three nations actively dispute who controls the actual territorial waters flowing between them. This centuries-old territorial gridlock ensures that the bilateral cooperation and the billions of dollars in shared funding needed to execute a project of this scale will simply never materialize. Once you factor in the massive shipping traffic, the shifting tectonic plates, and the political hostility, you have to reevaluate what the Strait of Gibraltar actually is. On a map, it looks like a broken road that needs to be connected. But to the global economy, the strait relies on remaining a completely empty, frictionless highway. Forcing a physical bridge across this gap wouldn't solve a transportation problem. It would actively jeopardize the delicate ecosystem of global maritime trade and ignite political powder kegs on both sides of the water. Millions of years ago, tectonic plates engineered this gap to act as a vital replenishment valve for the Mediterranean Sea. It works flawlessly, exactly as it is. Until a radical, invisible new technology arrives, the best way to cross the dangerous, politically fraught divide between Europe and Africa is exactly how it has been done for millennia: on a boat.